Hi, welcome back to Intermediate Algebra. We're looking today at section 6.5, equations with radicals. So we're looking at things that have square roots, cube roots, fifth roots, I don't know, all kinds of good stuff. So to do this, we're going to work with something called the squaring property. Now this will also work with third powers and fifth powers, but we're just going to specifically right now look at the squaring property. And it just says this: if a and b are equal to each other, then so are a squared and b squared. And that seems perfectly reasonable to me, but there is a catch. Squaring might result in solutions that do not work. And I have here a very small example to show us how this can come to be. So I have the square root of x equal to -5. And as hopefully you can see, I've squared both sides to try and get that x out of the square root. Right? Because if we square a square root, the square root disappears. Very nice. We get x. On the other side, if you're careful and you actually square -5, you get positive 25. So x appears to be 25. Seems like a great solution. However, if we take that 25 and plug it back in, the square root of 25 is 5. It's not -5. And so this is what we're going to call an extraneous solution, and I'll write that on the board here at some point. But that's what's called an extraneous solution. It doesn't work. And so, honestly, all we're going to do at this point with that is we're just going to cross it out. If you want, you can write it extraneous, because it is a solution that pops in because of the multiplication that gives us, that's something that doesn't actually work. So let's get into this section. Let's dive into some examples. It's not a real long section, and so let's have some fun. All right, so continuing on with some more examples. First I have the steps for us, and then we're going to have this example, and then we'll have more examples. Loads of fun to be had. All right, so step 1, isolate the radical. Okay, you cannot do one of these problems with the radical not by itself. So case in point here on this first example, I have the square root of 5x plus 1 minus 1 is equal to 5. Right now, we can't solve this. I mean, technically we could, but really the easiest way to do that is going to be to get rid of that 1 first. And as you can see, that's what I did with this equation. I added 1 to both sides so that I had the radical by itself. And that's very important. It's one of the most commonly forgotten steps. A lot of people just start squaring stuff right away. They're like, hey, I got a square root, let me square stuff. Unfortunately, remember, you're squaring the entire side, so what you would really have is a set of parentheses around this, and you'd have to multiply it by itself, which is going to create a big mess and not even get rid of your radical. So anyway, get the radical alone first. Step 2, raise both sides to the index. So in this case, I'm using a square root, so that means, of course, that my index is 2. If you have a cube root, you're going to use a third power, and so forth. So you can see after I got the radical alone, so I had the square root of 5x plus 1 is equal to 6. Now I get to square both sides because there's only one big piece. I mean, admittedly, it's a big, ugly, nasty piece here. But there's only one piece. So I can square that whole thing, which gets rid of the square root, leaving me with 5x plus 1. And on the other side, 6 squared is 36. Now we go ahead and solve, just like you would whatever kind of equation you've got. So I subtract the 1 to get 35. I divide by 5, and it looks like my answer is 7. But we do need to do one more step. We have to check our solution, because as we saw in that very first example, sometimes the solutions don't work. In this case, we can take the 7 and plug it in. You can see I plugged it in over here. I just want to make sure if I plug in 7, that when I work it all out, I get 5. And you can follow through that, and you can see that it worked. We got 5. So we have a good solution. We're going to keep it. We're not throwing this one away. So let's do some more examples. Okay, so on this board, this is all one example. Unfortunately, you will use a bit of paper here. So if that bothers you, if you're concerned about, the trees, use some recycled paper. Anyway, here we go. X minus 9 is equal to the square root of x minus 3. So this time we're lucky. The square root is all by itself, so I don't have to do anything with that. However, when I square both sides, I have to remember, and I kind of talked about this with the last example, but when I square this left-hand side, I'm squaring that whole thing. We can't just square x and the 9. We have to square it as one big entity. We're squaring the whole left side, we're squaring the whole right side. So when we do that, on the right, we get something really nice. The square root and the square go away. We just get x minus 3. On the left, when I multiply that out, if you trust me, it's x squared minus 18x plus 81. If you don't trust me, and you probably shouldn't, multiply it out for yourself. See if you get that. 99.9% sure I'm correct here. So, anyway, I have x squared minus 18x plus 81 equal to x minus 3. Now, I have a quadratic, right? I have a 2 there, which means I'm going to subtract x from both sides and add the 3 so I can get a 0, which gives me x squared minus 19x plus 84 is equal to 0. And now I can go ahead and factor it. That's our only option really at this point. We haven't learned the quadratic formula. We can't solve here by taking a square root because we've got all kinds of mess going on. So I have to factor it. It does factor to be x minus 12 times x minus 7. If you need a review of factoring, go back and look at the beginning of this course and you will find a video. So anyway, I have it factored, and since it's equal to 0, I can split it up. X minus 12 is equal to 0. X minus 7 is equal to 0. Add 12, we get 12. Add 7, we get 7. It looks like two really good solutions, but you'll see that I've checked my answers here. The 12 works just fine. 12 minus 9 is 3. On the inside of the square, right, I'm plugging it in here. On the inside, 12 minus 3 is 9, and the 3 is equal to the square root of 9. So that one checks out. I get to keep the 12. However, on the other side, with that 7, we're going to have a problem. 7 minus 9 is negative 2, and when I take the square root of 7 minus 3, I get 4. Square root of 4 is 2, but it's not negative 2. Right? This is the positive square root we're looking at here. So those are not the same. That's why I had this x here. It turns out that this 7 is extraneous, so I'm just going to mark it out. If you want, you can write extraneous, but basically you just have to throw it away because it doesn't work. And so anytime we solve when we square both sides, we introduce this possibility that we get a solution or all of our solutions that just actually don't work. So, all right, I have one more example I want to go through, and then we're going to call this section good. All right, last section for today in this section that we have. Square root of x minus 1 is equal to the square root of x minus 1. Okay, so this one, the first thing you might notice is we have two radicals instead of one. And unfortunately, even though the one on the left is by itself, the one on the right is not. And we can't get them both by themselves. I have this annoying, pesky little minus 1 running around, and it's no matter what I do with it, I can't have just the radicals completely isolated. So what I'm going to do is I'm still going to square both sides. This is going to work out okay. It's maybe not going to be your favorite thing ever, but it will work out okay. Since the one on the left is isolated, when I square it, I just get the x minus 1 that was on the inside. On the other side, though, again, this is something that where I'm multiplying squaring that entire side, I'm going to need to FOIL it out. So I did that. I didn't write it out on the board, but when you do, you get x minus 2 square roots of x plus 1. So I encourage you to go back and multiply this by itself, just to check and make sure that you know how to get that piece. So, unfortunately, at this point, I have x minus 1 equal to x minus 2 square roots of x plus 1. And that has another radical in it. Okay, we did not successfully get rid of all the radicals in one step. So basically, we have to do it all again. So we're going to isolate that radical, we're going to square, and then we're going to see where we're at. So I need to get this radical by itself. So I subtract the x, which gives me 0, right? X minus x is 0. That's actually really nice and very fortunate. I need to get rid of the 1, so 1 minus 1 gives me 0, so I use a negative 1. Here, negative 1 minus 1 is a negative 2, and so now I have negative 2 radical x equal to negative 2, so I just divide both sides by negative 2, which gives me 1 equal to the square root of x. There we go. Now that radical is by itself again. I can square both sides, and that leaves me with x is equal to 1. And sure enough, if you go back and plug in 1, you get 1 minus 1 on the inside, and that's just 0. Square root of 1 is 1, minus 1 is 0. So both sides are equal to 0, and that's just what we want, right? We want those two sides to be equal to each other. So there we go. That's solving things with radicals. I didn't look at any examples here with higher indices, but the key is they're going to work the same way. Get that radical by itself, and then use whatever power you need to get rid of the radical. So if you have a third root, you're going to use the third power. If you had a 20th root, you would use the 20th power. Let's really hope that never happens. But the example holds true. You can use, as long as the index and the power match, the radical will disappear for you. So there you go. Have a wonderful day. Thanks.